Okay, we're going to start with some definitions. Number one, an angle is two rays with the same initial point. Number two, the measure of an angle is the amount of rotation required to rotate one side, which is called the initial side, to the other side, called the terminal side. So just to put a little bit of context, if this is one side of our angle, the initial side, the angle measure comes from the amount of rotation to the terminal side. So this amount of rotation is where your angle measure comes from one side to the other. Number three, the shared initial point of the two rays is called the vertex of the angle. So this point right here on this angle would be its vertex. Number four, an angle is in standard position. An angle is in standard position if its vertex is at the origin of the rectangular coordinate system and the initial side lies along the positive x-axis. Let me see if I can draw a little example. So we've got our x and y axis on the coordinate plane. Standard position is the vertex is at the origin. The initial side is right here on the positive x-axis. And then the terminal side could really be anywhere. Could be, let's just say it's over here. So we rotate the initial side over to the terminal side to get our angle measure. But the terminal side could be anywhere. As long as the initial side is in this position right here, then that is in standard position. Okay, number five, if the rotation of the angle is in the counterclockwise direction, which is what I just drew right here, rotation from the initial side to the terminal side, I went counterclockwise, that is a positive angle. If the rotation is clockwise, then the angle is negative. So that's probably something new that you haven't really dealt with before is negative angle measures. All that means is from the initial side, you've gone clockwise instead of counterclockwise. It's more of a direction than anything. Number six, two angles in standard position that have the same terminal side are said to be coterminal. A lot of these things will become a lot more clear the more that we talk about them and use them in examples. But I just wanted you to have them all in one spot, all of those definitions. Okay, let's look at converting between radians and degrees. A radian is just another way to measure an angle. So just like we have a bunch of different ways to measure length, we have centimeters, inches, feet, yards, miles. We have all of those different measures. Radians is just another way besides degrees to measure angles. So if we want to convert 360 degrees, that is the same as 2 pi radians. 180 degrees is pi radians. One degree is the same as pi over 180. You're gonna get a lot of practice. There's a lot of pi symbols in the unit circle. Okay, 1 radian. One radian is 180 over pi degrees. I don't really know where to put the degree symbol on that. Maybe if I did parentheses. That looks like I'm raising it to the 0 power. I don't know.
Doesn't make sense that radian is better than It's radians, radian.
That's probably the correct pronunciation, but because we live in the South, Radians. Okay, so to change from degrees to radians, you're going to multiply by pi over 180. To change from radians to degrees, you're going to multiply by 180 over pi. Not usually, because it'll change pi to a decimal, but we don't really want to do that. It will get less and less confusing the more we go, I promise.
That's what every teacher has ever said, and it's still never come true.
It never gets easier. Okay, let's look at these examples. Convert the following degree measures to radian measures. So to convert from degrees to radians, we multiply by pi over 180. So if we want to change 120 degrees to radians, we need to multiply by pi over 180. Okay, when we multiply a number times a fraction, that number just gets multiplied in the numerator. So we could write this as 120 pi over 180. Yes, we will go a little bit further. We don't want to change this to a decimal. So if you're going to put this in your calculator, just leave pi out of it. You leave the pi out of it, okay? It's not, it didn't do anything. So you just put 120 divided by 180 in your calculator and simplify that fraction. It should simplify to 2 over 3. So this would be 2 pi over 3.
Why is the pi symbol next to the 2 and why not?
It could be 2 over 3 pi, but I would write it this way. This is the way that you're going to see it in the unit circle. This is the pi in the numerator. So 120 degrees is the same as 2 pi over 3 radians. And we don't really have to write radians every time we write a radian measure. If there's not a degree symbol, then it's usually understood to be in radians. Yes. Yes. Huh? A radian is just another way to measure an angle. This is like, so pretend when you learned measurements, you were never told about feet. You didn't know that you could measure things in feet. You only know inches. And now I'm telling you, feet is just another way to measure length. And to get feet, you divide the number of inches by 12. And that's how many feet that is. So it's similar to this. You've only, huh? No, you multiply by pi over 180. So you've only ever heard about degrees. Now I'm telling you there's another way to measure angles, and it's called radians. The way that you get to radians is you multiply by pi over 180, and that gives you the radian measure. A little bit better.
And then, so would it be,
So if we want to change negative 315 degrees, we want to change that to radians, what do we do?
multiply by pi over.
Yes. So this would be negative 315 pi over 180. Negative 315 divided by 180. If you do that in your calculator and change it back to a fraction, you should get negative 7 over 4. So we've got negative 7 pi over 4. Sorry. So negative 315 degrees is the same as negative 7 pi over 4 radians. All right, let's look at example 2. Convert the following radian measures to degrees. So to convert from radians back to degrees, we multiply by 180 over pi. So we've got 5 pi over 6. We want to change this to degrees. So we multiply by 180 over pi. For multiplying two fractions, you multiply straight across. So if we multiply the numerators, 5 times 180 is 900 pi over 6 times pi is 6 pi. We can simplify here. The pi in the numerator and the pi in denominator. Pi over pi is just 1, so those basically cancel out. And then we can do 900 divided by 6 to get 150 degrees. And that is our answer. Okay, we've got 7 radians that we want to change to degrees. So we're going to multiply by 180 over pi. Seven times 180 is 1,260. And then we've got over pi. This can't really be simplified. This is our answer in degrees. I don't like it either, and we won't be seeing answers like this really. I just wanted to show you, even though we don't like the answer, we converted this correctly. Questions so far? Everyone doing okay?
Mental health, no good.
Like, I'm not confused. I
My
know
stomach
how to do
hurts.
it.
Yeah.
I don't know how relevant that is.
So I think a lot of the things that we've done so far this year are things that you at least learned a little bit about before now, but the unit circle section of trig pre-cal is something that you've probably never seen before. So it's understandable that it's, yeah. Okay, next page.
I think there's an alien calling its way out of my stomach.
Okay, sketching and finding coterminal angles. So, number one, we've got theta. This symbol right here, it is a Greek letter called theta. And theta is just the variable that's most common when talking about angle measures. So like the most common variable you've seen up to now has been x. We use x for everything. When you're talking about angle measures, this symbol theta is the most common variable used.
I got scared when we brought the alphabet in. Now we're bringing the big alphabet.
Yeah, exactly.
Great one been there.
Okay, let me take a second to explain coterminal angles. So you guys don't have to write this, just pay attention. So if I were to have a track, this is a track around a football field. And let's say Georgia and Tanner start walking the track at the same spot. They both start right here. And let's say Georgia walks not quite a lap. She stops right here. Tanner walks an entire lap and then walks another lap up to this same spot where Georgia stopped. So they both started at the same spot and stopped at the same spot, but Tanner walked a full lap more than Georgia. Does that make sense? Yeah. That is coterminal angles. Yes, so.
So it don't matter how many times I go around, as long as it's not.
Yes, so all of our angles.
What angles are like sharp?
What? Well, it's this. Okay, so we have two angles that are starting right here. One angle is going to rotate around to here and stop. No. Well, it's fine if you want. But another angle is going to go a full rotation and go all the way around to here. So this first angle that I drew is probably about a 300-degree angle. Around from here to here. The second angle is going to be about a 300-degree angle plus a full rotation, which is 360 degrees. It does.
What does it have to do with 13.5?
Nothing yet.